All right, so we have total differentials as another topic. Now you're giving let z a function of x comma y or a function of x and y. Okay, so like let z be a function of x and y. This is how you write it. Now dz normal d is equal to partial z over partial x dx plus partial z over partial y dy. How do I explain it? Z is a function of x and y. X is an independent variable, y is an independent variable. So now, independent z, that is the differentiation of the independent z. I guess when we look at the next one, it's going to make more sense. Is equal to z is a function of x and y, so definitely it's going to use a partial since it's a function of x and also a function of y. So you have partial z over partial x times dx plus partial z over partial y times dy is equation 1. Now equation 1 is called the total differential of z with respect to x and y. Now if x from here now from equation, if x is a function of t and y is a function of t, so when we talk about single variable we use the normal differential. When we talk about multiple variables we use the partial differential. So when you say z is a function of x, x is a single variable, so we just use the z over the x is equal to 1. When you cross multiply, you have the z is equal to the x and the x. That's what's happening here. That is what is happening here. Sorry. So for this now, let me explain it. So z is a function of x and y. It means that z can be expressed in terms of x and y. That's what function means. So you can express z in terms of x and y. But x now is a function of t. Y is also a function of t. So it means that wherever you see x and y, they can be expressed in terms of t. So if you're having a z equation with x and y, and then x and y are terms of t, it means that you can substitute t for x and y. So when you substitute t for x and y, you have a z that is just a function of t. I don't know. Listen to it again. I'm sure you understand. If you don't get it once, let me say it again. Z is a function of x and y. Z is a function of x and y. It means that the expression z can be or z can be expressed in an equation form in terms of x and y. But now x is a function of t, and y is also a function of t. So if you're given an equation, let's say z is equals to 3x squared plus y, and we say x is a function of t, that is x is equal to maybe t, 3t, and we say y is a function of t, and let's say y is also 3t. Substitute it here, you're going to have z is equal to 3 bracket 3t squared plus 3t. Z is equal to 27 t squared plus 3t. So now z is just expressed in terms of t, so z is also a function of t is what I'm saying. So let's come back here. Now since z is a function of t, we are going to use, since it's a single variable, so we are going to use normal d. That's what we have here. So dz over dt is equal to partial z over partial x, since z is a function of x and y. Z now is a function of x and y, so partial z over partial x times x is a function of a single variable t, so you have the normal dx over dt plus partial z is also a function of y, partial z over partial y times y is a function of the single variable t, so dy over dt. So this is a formula you need to know. I've told you how I understand it. Why we have normal dz over dt here is because when you express everything in terms of t, like if you say z is a function of x and y are functions of just t, so z is also a function of t, and when z is just a function of t, we say it's normal dz over dt. You understand? Okay, I guess that's the point. So now when z is a function of t, dz over dt, but you don't forget that z is a function of x. So recall, you use partial when you're having two variables, and you use normal d when you're having one variable. So z is a function of x and y, which is two variables. So when you want to find the z over dx or the z over dy, it's going to be partial. But x and y are functions of a single variable. So when you want to find the derivative, you're going to use the total dx over dt. Now let's see a question where we can apply this formula. Given the base arrow of a cone is decreasing at the rate of 0.1 cm square, while the perpendicular height h is increasing at the rate of 0.2 cm square, find the rate at which the volume v is changing when r is equal to 2 cm and h is equal to 3 cm. So now what are we looking at? We're looking at a cone. We're looking at, they said you should find the rate at which the volume is changing. Volume, that's what we're looking for, and we need the cone. So now you see, let v be the volume of the cone. The volume of the cone is 1 over 3 pi r square h. R square and h, two variables. So when we are differentiating, it's going to be partial differentiation. We differentiate partially with respect to r, differentiate partially with respect to h. Now differentiation partially with respect to r is going to be 2r. 2 times 1 is 2 over 3 pi r h. Differentiate with respect to h, this is going to be 1, so you have 1 over 3 pi r square. Now dv over dt, because they say find the rate at which the volume is changing, like with respect to time. Since we have our cone and the radius is decreasing with respect to time, the height is increasing with respect to time, so the volume, the rate at which the volume should change, should be with respect to time. So dv over dt is equal to partial v over partial r times the r over dt plus partial v over partial h times dh over dt. The r over dt is equal to, is decreasing at the rate of, so it's going to be minus, while the h over dt is increasing at the rate of 0.2 cm per second, so it's positive. Oh yes, it's positive. So now let's put in the variables for these the values for these variables rather. So dv over dt is equal to partial v over partial r is this, times the r over dt is minus 0.1 plus partial v over partial h is this, times the h over dt is 0.2. Now you see, when r, if you come back here, they said when r is equal to 2 and h equal to 3, you have it that dv over dt is equal to 2 over 3 pi times 2 times 3 multiplied by minus 0.1 plus 1 over 3 bracket pi brackets 2 square times 0.2. Now recall is volume. Volume is cm cube per second. Don't forget your SI units. So the v over dt is equal to, when you open this stuff, you're going to get minus 0.4 pi plus 0.8 over 3 pi centimeter cube per second. If you just use your calculator and do this, you get minus 0.1333 pi centimeter cube per second. Put in your value of pi, and this is the answer you get. Okay, so that's it for total differential. We'll come back to this in the next video.